So in modules 8 and 9 we're going to talk about verification. And again I refer to the textbook on chapter 9, required reading of course. And there's a couple other references in here, including a NASA software safety guidebook which is available on the web. D0178C, and I've said this before too, is not available. Just a couple of excerpts are given. Alright, so in D0178C, the software verification process is really part of the integral process sections. So if you look at software verification, it really is more or less a technical assessment of the results of both the software development process, in other words, where you start deriving high-level requirements, low-level requirements, source code, and object and executable code, as well as the verification process itself. So what you hope to achieve is that due to all the things that you're doing in the verification processes, that you're detecting errors and that you report them, and that of course that you take action and fix the problems. And that all will result then in a reduction in the number of errors that is present in your code, hopefully reducing it all the way to 0. Yeah. Now, one important thing to say on this slide is that verification is not equal to testing. Testing is really part of the verification process, but testing is not the whole verification process. Now, as I said before, in 61508, they use a V lifecycle model, so their verification is also seen as a very important aspect of life cycles. Okay, let's look at it. So we saw before that we, in the D0178C development process, we're trying to capture the requirements. In order to capture high-level requirements, for example, textual requirements. Then we're actually going to break it down and we're going to go to the design phase in which we start to capture low-level requirements that then will be coded up. And of course, in the end, the code will be compiled and integrated with the hardware. Now, in all these cases, what the verification processes are taking place in parallel, and what you're going to hope that there's a feedback mechanism where you try to detect errors and then fix them in your development process. Basically, when you start out with verification, you need to start out with a verification plan. And this plan, of course, needs to include who's going to be responsible for what activities within verification. Another important thing is that you're going to discuss how you're going to deal with independence. We saw this before in these objective tables. A lot of these bullets are solid, they're black. That means that these particular objectives need to be performed with independence. Now, of course, you need to include what kind of verification methods you're going to use. Are you going to use reviews? Are you going to perform analyses? What kind of tests are you going to use? What kind of methods are you going to use when it comes to testing? And of course, in what kind of environment are you going to do that? Do you have particular hardware test equipment? Do you have test and analysis tools? All these things need to kind of be established in the plan already. Of course, like any other life cycle item, is you need to have established transition criteria to find out exactly when you conclude a particular process, in this case specific to verification, of course. Now, there's a couple additional items in this plan. What are you going to do in terms of partitioning if you run multiple software components on the same processor? What are some of the compiler assumptions that you do? What kind of compiler are you using? What kind of linker are you using? How are you going to then take the compiled and linked code and put it on your hardware platform? We refer to this as the loader. And also, what are you going to do when you have to change certain object code? How are you going to verify that? Now, in those cases where you use previously developed software, you need to include this in your plan. And of course, if you use multiple version dissimilar software as part of your system, then you need to also address that. Now, there's a variety of tables. I'm not going to talk about all these tables in detail. We have the verifications of the outputs of the software requirements process. So in this case, you say I'm going to do the software requirements derivation and I'm going to verify it. So these things include high-level requirements comply with the system-level requirements. They're accurate and consistent. They're compatible with the target computer. They're verifiable. In other words, I can verify them somehow. I can come up with a test case for it. And of course, they conform to the standards that you have established. And then of course, they must be traceable to the system requirements. Again, don't forget, traceability is not equal to compliance. And we'll talk about it some more. And of course, at the end, you need to make sure that these algorithms are accurate. Yeah? So these are just a verification of the outputs of the software requirements process. So if we go down one level in hierarchy, there's a similar table for the outputs of the software design process. And you see, these are kind of the same things that we talked about on the previous slide. We did check compliance, accuracy, consistency, compatibility, verifiability, conformance, traceability, and algorithm accuracy. Needless to say, in the software design process, we really talk often about low-level requirements, but also the software architecture. And if you talk, so that means also that all these items, these attributes like compliance and accuracy and consistency, are also valid for the software architecture. Now, if you talk again one level of hierarchy down, we're going to go software coding and integration. There's also a set of verification activities, which are given right here. Now, there is some specific testing objectives in D178C that you really didn't see in D178B. You can see here, this really results to that the executable object code that you have complies with the high-level requirements. So you see that here we're relating the object code, the output of the integrated process, where we have taken all the modules, compiled them, linked them together, and we compare them directly here to the high-level requirements. Also, we check them or verify them against the low-level requirements, and of course against the target computer on which this executable object code must operate. Now finally, there's also an item called verification of verification processes. In this case, you're going to really check out if all your verification activities have been sufficient or were correct. So you're going to check out if my test procedures that are derived and used are correct. If there's test results, if their test results have been generated and if those are correct. And if there is discrepancies in these test results with what you would expect if you have actually explained those away, and if these resulted in fixes of either low-level source code, low-level requirements, or high-level requirements. And a couple of other things that we actually check for software structure. And we're going to talk about this in way more detail in the second part of this verification.